Hello everyone. In this video, I'm going to talk about how I set up my simulation for a chess robot. So my main motivation was this GitHub repository where uh, this person uses uh, UR5E to pick up Lego blocks and assemble it. And thus he uses computer vision to detect where the each block is and determine the pose to pick the blocks. What I wanted to do was to do the same thing, but with a chess robot or chessboard, so that you can pick each individual chess pieces and move it, and you could simulate an human playing with a robot chess game. So the problem had starting it was that there was no custom world files, which you'll understand later on in this video, to create the simulation. So I had to create the chessboard and the chess pieces to simulate it. And I would be walking you through the steps I had gone through to do the setup so that you could set up your own simulation later on. At the beginning, the first thing what we need to do, and while you're creating any packages in ROS, we need to create a workspace. So first we create a workspace, and then once we create a workspace, we create a package and with dependencies like ROS CPP, which is for C++, ROS Pi, standard messages, and URDF. And once that is done, we build the packages by using catkit make. And then once that is done, we also try to add in some more subfolders inside the package so that it's in a good structure. Basically, the structure would be like you have a launch file, you have a file which stores all the models, and then you have a file which has the scripts, and you have a file for having all the world, which you'll see later on. So in order to create a gazebo world, we would first start with a model. And to create a model, we can do two ways. Either we could have a pre-built STL or DAE OBJ files, which are all uh, files we can get from a 3D CAD model, and then we can import that in order to create our model, or we can use the primitive shapes available in Gazebo to create the model. Once we have imported the STL files and we have made a model which consists of links and joins, we use that and create an SDF file. This SDF file is a file which can be used then later on to create the world file, which has the physics simulation, and it's where we do the simulation. So this video kind of explains how it's done. So here I'm using a custom STL file. This is a STL file for a chess piece. Here it's a king, and it's a STL file which I then imported. And once I imported, I just set it up on the in the world. And after setting it up, I open the link inspector. Here is where you can change the inertia or the mass of the link, or you could add different properties in terms of the visual appearance, as in the color, texture, and also you could define the collision, that is, which would be later on used during path planning. So once this is done, we set this up and save the whole file. Uh, we give it a name, and then we also give in a description and the name of the author and the mail IDs. And once this is done, we will get the SDF file, which you would see here. Uh, So now if we open this up, we'll have an STF file and a config file. And this is an STF file, which is kind of like a Zacro file. And this is an STF file for this particular piece. Similarly, we would have to do it for each and every single chess piece we want to import in the simulation, as well as the chess board, which we use it in the simulation. Um, yeah. So if you can see in this video, I pull in custom model, which the Gazebo itself offers, like a table. And then I pull in all the STF files which I created, like the chessboard here. And then I bring in a chess piece, a king here, and then I align it using the align functions here and move it to the respective position I need it to be using the moving function here. And once I do this for all this single all each and every pieces, I get a fully set up chessboard in the simulation world. And when we save this file, we get another world file, which you can see here. And this has the description about what are the models being used, where it is positioned, what is the physics simulation being used in this whole setup. Once this is done, we then create a launch file. This launch file is created so that we could just run this launch file, and then we can have the entire world which we created just spawn in the Gazebo window. So while doing this, this can be a little tricky because we need to have this line where we say the environment name, and we specify the path where Gazebo has to look into to get all uh, the STL files which we had used before. So this particular line is very important. Otherwise, we will not spawn all the other custom SDF files which you had created, and that would not lead to a result which you need. So once everything, all the launch file and everything is set up, you could run the launch file. And once you run the launch file, you would be able to see your entire world spawn. And this would be the final result where you have a chessboard and the chess pieces all set. So my next step after this is to set up an UR5E robot on the simulation and then use move it to plan to get the robot to move and pick each pieces. So with this, I would like to thank everyone for listening to this video.